In this video, we're going to reverse the order of integration right here. This time we're working with a double integration that includes e to the x power. Okay, so our final double integral should look something like this, dx dy instead of dy dx. We want to begin by listing all the x values. So x is equal to 1 and x is equal to 0, and then list all the y values, y equals to ex and y is equal to x. Then we want to graph these lines and curves. So the line x equals 0 looks like this, label it. X equals 1 looks like this, label it. Y equals 1 looks like this, label it. And y to the ex looks like this, label it. Okay, so if you want to shade in our region will be right here. Now, next step is to set up your double integral form. So basically bringing this down, or you could just remove this because we have this now. Now we want to find the inner boundary of dx, we want to find the upper boundary, and we want to find the lower boundary. To find the upper boundary, you want to see what equation determines the end of the x-axis. Okay, so for the upper boundary, it would be this line right here, x equals 1, therefore it's gonna be 1. Now for the lower boundary, it's gonna be this line right here, y equals ex. However, we are going to need to solve for x. So y equals ex. In order to solve for x, we're going to multiply by ln. That gets rid of the x. No, that gets rid of the e. So multiply by ln. On both sides, you get x equals ln y. Okay, so you have ln y here. Now to find the boundaries for dy, you want to see what line or curves or equation determines the end of the y-axis. So right off the bat, we see that the lower boundary ends at 1 because it's this equation right here. This equation sets where the y-axis ends. So this point. Now to find the upper boundary, you see that it's going to be the combination of this line, y equals ex, and the combination of x equals 1. And in order to find the upper boundary, you substitute x equals 1 for x here. So you have y equals e to the 1 power, which if you plug it into a calculator, you don't even have to plug it into a calculator because a number times to the 1th power is going to be the number itself. But I just want to show you, if you put e to the 1 power, you get e, which, yeah, same thing. It's gonna be e. Okay, so your upper boundary will be e. Now this will be your reversed order of this double integral.